Hello guys, welcome back to my channel CS Logic. So in this video I'll be explaining you what is traversing linked list in DSA. Before getting into the video, I would request you to subscribe to my channel because this is a computer science based channel. I used to post theory as well as practical videos, and if you are a computer science student, then it will be a useful channel for you. And for the final year students and people who are seeking for a job, I'm posting a IT job alerts in my WhatsApp and Telegram channel. If you are interested in those, you can check it out, the link in description, and you can join those. And yeah, let's get into the video. What is traversing a linked list? So before seeing this video, I would request you to see another video, linked list in DSA. So before I'll post that link too in description. You can check it out if you didn't watch that yet. And yeah, let's get into this video. What is traverse? So traverse is nothing but processing each node exactly once. So this is what traversing. So we are going to access each and every node, every element, and we are going to apply some type of process in that node. I hope you know what is linked list. So this is how a linked list look like, and this will start with a start, which is a pointer, and goes to the info part, again the link part. So it will do it until it reaches the X mark. So this is what linked list is. So we are going to access all the elements from the starting point to the ending point. So to the end of the list, and it will happen in a sequential manner. And for example, you can take a simple example for this is media player. You can play back the song, right? You can go back the song, whatever you listen previously, and you can go to the next song also if you want. So a media player is simple example for a linked list. We are going to see the algorithm for this linked list traversing. So it includes list. So it basically have list. List means linked list. It represents a linked list. So pointer means the point, the pointer which this is nothing but something which points the currently processing node. And info means the information part. Link means the address part, and starting means the starting of the list, and end. This is the starting. So starting of the list, and end means X mark. This null means the end of the list. And pointer variable. So pointer variable here is PTR, which is equal to link of PTR. So you can see here, this is PTR, and here you can see one dot. So this is the address. Okay, so this is the address, which is nothing but link of pointer. So it start with the pointer, start with link of pointer, and again it will move to the information part. So once it reaches the information part, it will change as info of pointer. Again once it is processed, and it will move to this link of pointer again. So it will update automatically. The pointer will be equal to link of pointer. So we can see the steps, and then we'll see how to write an algorithm with this. So as you know, this is the linked list. So it will start from this start, okay, and it will go with this. So we will be initializing this pointer or start first. Okay, so the check pointer value, whether it is null or not. So first step is we are going to initialize some pointer or start, and once it is done, the pointer will be either null or not null. Okay, it will be either null or not null. So if it is null means it will exit automatically because it does not have any nodes. So we need not to waste our time by processing nodes. So once it is null, we can exit the loop. We can exit the state, we can exit the algorithm itself. But if it is not null, so while it is not null, we need to do some steps. So what we are going to do is we are going to process this information, again move to this, we will be updating this link. So once it moves to the link, it will move to the information part automatically. So it will process this information and again update the link. So again move to this information processing, again move to link. So this will happen until it reaches the X mark. So this is what we are going to see here. So it will process the information of pointer, again update the pointer as pointer equal to link of pointer. Again second node, for the first node it will have done. Okay, the second node, move to the second node, process information of the pointer, again update the pointer as link of pointer. So it will continue till it reaches the X mark. Okay, once the pointer is equal to null, it will automatically end the list as exit. Okay, we can exit the list once the pointer is null. So this will happen until it reaches the null. Okay, so this is what we are going to see as traverse. We can start with the algorithm. So for the algorithm, what are the things we are going to see is we will be having the list, which is the linked list, and pointer. So pointer, as you know, pointer is nothing but which point out the node which is currently processing, and the operation we are going to do here is process. So the operation here is process. Yeah, that's about the basic thing. Okay, so we'll move into the steps. So first step, in the first step what we have did, I'll draw the diagram here. So this is the linked list diagram. Okay, so what we are going to do now is we are going to write the algorithm based on the steps. Okay, so first what I did is I'm just assigning this pointer equal to start. So we are going to set the pointer equal to start. Okay, this is the first step. So next what we did is we are checking whether this pointer is null or not null. If it is null, we need to exit the loop, and if it is not null, we need to continue with the nodes. Okay, so while the pointer is not equal to null. Okay, not equal to null. So if it is not equal to null means we are going to process this information part. Okay, again moves to the link of the pointer. So we are going to apply process to the info part, info of pointer. So once it is done, what we'll be doing, apply it will automatically update to the link. So set pointer equal to link of pointer. So this actually represents the next node. The pointer now points to the next node. Okay, and what is the next step here? Again it will move to the next one, right? It will process this information. So it will move to the pointer. Again it will move to the information and link, information and null. So these two steps are again, so this is something like a loop. So what I'm doing here is I'm using while. So while the pointer is not null, it will apply these two. Okay, so here I'm executing like end of the loop. I'm giving the end of loop. So once it will apply the process. If the pointer is not null, it will move to the information part, again link part. So again it will check for the pointer is not null or null. It is not null, so it will move to these two. Okay, these two steps, and it will process update. So again check for the pointer is null or not null. So it will process this one also. Again it will move to this information of the, so information is processed. So here you can see the info, the pointer is not, okay, the pointer is null here. So if the pointer is null, what will happen is this while loop will not work, because the pointer is not equal to null is the condition, but here the pointer is equal to null. So here we are going to give exit. So what will happen is if the pointer is not null means it will go to these two steps. If the pointer is null means it will automatically exit. So this is how we need to write the algorithm. So this is the algorithm for the traversing linked list. So this is step 1, step 2, and this is the step 3 and 4. So 5. So here we are repeating the step 3 and 4. Okay, I hope you understand how to write algorithm. So we can see a simple example how to print all the link, like all the nodes in the linked list. So here there is only one change, because as we know we are going to start with this and we are going to print this. We are going to, again it will update as the link. So here we are going to change only one line, which is this step, the third step. So we are going to write it as write link info of pointer. So this is a simple step. So we are going to just change this step 3 alone to print all the nodes. So suppose if you want to count all the nodes means what you need to do is, so to count I'll start with 0. So this is 0 means 1 2 3 4. So 4. So start with the 0, 0 plus 1, 1, 2, 3, 4. So number of nodes here is 4. So how to count in algorithm? Okay. So here I have considered 1 0, right? So for this I am going to declare one variable which is num. So I am going to set num equal to 0. So you can say it as initialize num equal to 0. So I am going to initialize one counter here. So here in the step 1 we are going to do that. And step 2, as usual, we are going to start with the pointer. So initialize pointer equal to start, and we are going to process this one, right? Process this one. We are going to check if pointer is not equal to null. If the pointer is not equal to null, means it will go to the, it will start counting, right? So here we are going to set the num equal to num plus 1. So this is the step here, and set the pointer equal to link of pointer. So it will point the link. Now it will go to the address part. Again the process will happen to the second node. So for the second node it will go to the while loop, and here the end of loop, and the last step is the exit. So the same steps only here also, 4, 5, 6. So the same steps also here also, but we are going to set num equal to 0 and set the number equal to num plus 1 to count all the nodes. So I hope you understand what is traversing in linked list. If you like this video, then give me a thumbs up, and yeah, if you have any doubts on this video, please do comment below. Also, if you want me to post any videos, please do comment below. I'll try to post the video as soon as possible. Thanks for watching. Bye.